Hello and welcome back to Calculus 1, section 3.8, Implicit Differentiation. So we are going to continue using chain rule heavily, except this one is going to be a little bit different because this section is talking about taking the derivatives of relations which are not functions. So far, we learned how to find the derivative of functions. We had polynomials, we had trig, we had all of these different kinds. Now, we are talking about the derivative of technically anything. Now, why? Why? And the answer is because all of these relations would have curves, and curves have tangents. And if there is a tangent line, there has to be a slope to that tangent line which came from the derivative. That means that anything that you put down on the paper must have the derivative. And the implicit differentiation is the one that will deal with figuring out that derivative.
Tangent lines, are they always horizontal?
No, only on the min and max points are horizontal when the slope is 0, but tangent line can be anything. So, and vertical is, which is infinite slope. You have that as well. Yeah, we can construct functions. We'll get there. I don't want to jump, but it's at the end of this section. So, if you look at y equals x squared, you know it's one of these guys. And you have tangent lines, right? Depending on the point you look at, there are tangent lines there. But then, if you look at the circle, we all know that the circle is not a function. But then, if you look at certain values, there are tangent lines again. So because there are tangent lines there, equation for the circle, let's say x squared plus y squared is equal to 9, the simple equation. It's not a function, yet we can take the derivative of it. So implicit differentiation is going to give us a way to take derivative of anything. So what I'm going to do now is I'm going to work on the derivative of a circle first. So say that you want to take the derivative of the circle. Observe that I included the entire equation into these brackets, and I'm saying take the derivative of it. We are going to take this derivative term-wise, and we are going to remember that y is f of x, which means that every time when I need to take derivative of f of x, I must use the chain rule because I'm taking the derivative of a function. So I'll write it here in blood. When we take derivative of a function, we must follow with a chain. And here it is. The derivative of x squared in respect to x is 2x. The derivative of y in respect to x is 2y times, you can put y prime. Or you can put dy dx, whatever. And then derivative of 9 is 0. So this is that part, the chain. So every time when I have to take the derivative of a variable that doesn't match the original variable, we have to follow with a chain. And there's going to be a lot of application to this as we move along. So all I need to do now is to work out the algebra here. So y is equal to negative 2x over 2y, y prime is equal to negative 2x over 2y. These guys cancel. And you can write dy dx, which is the derivative, is equal to negative x over y. That's the derivative. Observe that your derivative contains x and y value, which means that you would have to have both coordinates to calculate the slope. Not every, well, let's try more first and then we'll deal. So how about another implicit expression? So 2y cubed minus y squared plus 6x is equal to sine x.
For the negative x over y, is that the whatever for the entire circle?
Yes. So at any point at the circumference of the circle, if you give me x and a y, I will tell you what the slope is, because at that point you will have a tangent line. So yeah, what's the derivative here? 6y squared. What happened with y prime? Or dy dx, yeah. Minus derivative of y squared is? Yep. Plus? Equals? Cosine x. So you take 4 independent derivatives in this case. And every time when you take the derivative of y, follow with a chain. Now, group first 2 and extract y prime and move the 6 to the other side and finally get y prime alone. So now if you provide me x and a y, I can tell you what the slope is. So observe what happens, guys. When you take these derivatives and you have multiple y's, you're going to end up with multiple derivatives, right? The only way to put them all on the pile is to factor them out, which means what? You factor it, and then, so the first thing I did is I moved this term to the right because that term did not have a derivative in it, and left only derivative terms on the left, and then I factor that derivative, and then we go from there. Let's see how this one goes. Can anyone tell me what's happening in this problem?
Yeah.
What should I do?
It's going to be 3y prime plus sine y prime equals 2x. And then you got to factor out the y prime. No?
Nope.
Oh. I thought I was on a roll. Isn't your 3xy just 3, right? Plus sine. But the x and the y cancel. X and the y. Oh shit. Product rule.
Product rule. Product rule. You have a function x, 3x multiplying function y, which is the unknown function. So it's 3x times y. That's a function times a function. That's a product rule right there. Have fun.
Thank you.
So yeah. So we have one certified in the classroom. Scored 120 on the IQ test. Let's go. Let's go. You just completed the IQ test. Scored 120.
I told you so.
So now he earns the harder exam.
Yeah, right.
So I got you covered. Harder exam. Right, we don't know, right?
That's the form of that. That's that. Times g of x and y is y plus just x. So it's the g times y. If it'll say like
All right, let's yes.
am I on a roll? Oh, it's not
1 times y prime, yeah.
All right, let's take a look at this together. So this is, guys, this is a little bit tricky, so you have to really pay attention. So the first function is 3x. So copy the first times derivative of the second. Derivative of y is 1, but then we have to follow with the y prime. Plus, copy the second, which is y, times derivative of 3x, which is 3. Minus derivative of a cosine is negative sign. And then on the other side, we have 2x, derivative of 9 is 0. So now we make it nicer. And this is the term that you have to kick on the other side because it doesn't have y prime to it. Factor out y prime. And finally, be done. Right here. This 3y came from this 3y, which came from this 3y.
Yeah, I think that's not an greater, right? Your answer. Why is 3x plus sign y on top? Yeah.
Oh yeah.
They flip?
Yeah, they flip. Yep. So now it's a good time to talk a little bit about notation, because you encountered few different notations on the derivative. And I would like to kick off that discussion by writing y equals ax squared plus bx plus c, and then say y prime is 2ax plus b, y prime is x squared, y prime is x, and y prime is 1. Would anyone like to comment whatever you want to contribute on to what I just wrote over there? Is it right? Is it wrong? Is it whatever? Yes. These are all first derivative. That's what I claim. What happened? So stare at this for a second. Try to see if you would pick anything up from everything I wrote there. Yeah, I said these are all first derivatives, so all of these should be the derivatives of the original problem. So let's see.
Why do you change the derivative?
What do you mean?
You had the derivative at 2ax plus b. Why do you take the derivative of that and take the derivative of that? Where did x come from x squared?
Yeah, that's what I want to discuss. Where are these things coming from? If I want to take the second derivative, I would just say y double prime over here would be 2a. And then the third derivative would be 0 if I'm to continue taking derivatives. So I'm not talking about higher order derivatives. I'm just talking about the first derivative. That's all I'm talking about. Can anyone see what the hell is going on over here? Yep, I claim all of these are correct. And it's all with the notation, and we have to be, this is why we have to be very careful with the notation, and this is why the notation y and y prime are garbage. Right here. And it is going to be more, it's going to be even more outlined later. So look at this. Do we all agree that this is the derivative of y in respect to x? What is the derivative of ax squared? Well, we keep a as a constant. X is a variable, so x squared is 2x, so 2ax, right? And then the derivative of x in the next term is 1. So b times 1 is just b. And in the third term is c. So the derivative of c is 0, right? Now, and we know that's the first, so that's what it was. It was the derivative of y in respect to x. Now look at the next line. Do you see that this is derivative of y in respect to a? Who said that a has to be a constant? Right? Yx gets to be the constant, and it will be like me going over here in this room and I pick up, you know, someone's name to be the name, and then everyone else is, you know, sorry, you didn't make the cut. Why is x better than a to be a variable? Right? Is that that's discrimination, right? A can be variable as well. So if you look at this line, this is dy dA. Derivative of a would be 1. Its coefficient is a constant, which is x squared in this case. And the other two terms don't have a, so their derivatives are 0. Do we see that?
That to x squared, where does squared come from?
Well, it's x squared, right? It's a constant. The derivative of a is 1, and then x squared is a constant. What's the next one? Yep, dy dB. B is a variable, everything else is a constant, and there you go. And the last one, clearly, dy dC. So what is important is to pick up that these guys variables we take derivative in respect to. It is in the notation embedded what is the main variable. You have seen this before within limits. You remember how you had the limit age goes to 0, and then you had, let's say, age x minus 5 over 3, right? And you ignored x completely because it was age that goes to 0, right? So the limit as an operator was operating on age because age was the, let's say, variable for the problem. You completely ignored x. So that happens in differentiation. That happens in integration as well later on. These things, these dx, dA, they're not there for decoration as much as when you write the integral, this dx at the end will not be for decoration. Because in Calc 3, guess what? Right? and then in order in which you put them will matter. So you have to get used to these dx, dy, dA, whatever it is, because that tells you, hey, this is the variable for the problem. Everything else is a constant. Just keep copying it. So you can put any string of letters you want, A, B, G, M, X, Z, and put a square and a cube, right? And now it will depend which one is your variable. See, if I ask you what is the derivative of this in respect to W, what you're going to say? There is no W, so it's 0, right? Because W is the variable, which means that all other letters are not variables, they're constants. Constant times a 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 constant, they're all constants, that's 0. But if I go and I say dW dm, that means m is the variable, and that one becomes 3m squared, and you copy the rest because the rest are all constants. Do we see that? So this is extremely important. Extremely important. Now, another part is that we mechanically learned that every time when we take the derivative of y in respect to x, we follow with the chain. So now I would like to use the proper notation to do a problem. So say we have 4y squared minus 3x cubed plus cosine e to the y, just to make it annoying, is equal to 7. And I'm taking the derivative of this in respect to x, d dx. This d dx is the instruction. It says take the derivative of the entire problem in respect to x. X is a variable. Y is going to be dependent variable on x. So we know on the side that y is equal to f of x. So now what I'm going to do is I'm going to say 8y dy dx. I'm following with a chain. Guys, what I did is I said I'm applying this to a y, and that's why there it is, apply to the y. Now I'm going to apply the same thing to x term. I'm going to get minus 9 x squared dx dx, because I applied the derivative. So I took the derivative of x. You see, I got dx over dx. That cancels. That's why we never write them, but they're there. These guys don't cancel. So technically what happens here is I say the derivative of 4y squared is 8y. And then I say I took the derivative of y. Now, you see that it stays because dy dx it cannot cancel. On this term, I said the derivative of 3x cubed is 9x squared, and I took the derivative of x in respect to x. And I have to say every single one has to be taken in respect to x because that's what the problem started. So I have that part. Plus, here comes the double chain rule. We have e to the y plugged into the cosine, so that's negative sine e to the y times the derivative of the inside, which is e to the y, and I took the derivative of y in respect to x, equal to 0. So what's left? 8y dy dx. We used to write this y prime, but this is far superior. Minus 9x squared. Dx over dx, that cancels. minus e to the y sine e to the y dy dx equals 0. Move this term to the other side. Factor out dy dx. And there we go. Yeah, I can feel your pain. Actually, I lied, I can't.
So that dy over dx is another way of saying y prime.
Yes. It's a much better way of saying y prime, because y prime doesn't tell you anything about what was the variable that was made for the problem, which would create issues right there. Ready? All right, find the derivative in respect to m of 4m squared plus 3km minus sine k sine k equals to k squared. K is the function of m. Then don't do the problem. There's always a way around it. Quitting is always an option. That is not to be exercised, but it's there, yeah. You get up in the morning, you say, I really don't want to go to work. I don't want to go buy food. Wake up in the morning, say, I don't want to go to the bathroom. It's always an option to quit.
I guess I get the 3km.
And what is that? 3 kilometers?
Yeah.
Or we can just say it's a product rule. I know. Love this stuff. So, as you are looking at this problem, guys, this is coming up in 311, okay? Word problems with this. So, when you are looking at this problem, or actually when I'm looking at this problem, I go like this. Here's m. This is the independent variable. And the k, because of this thing here, k is the dependent variable. Depends on m. So this will always list what is your independent variable. That is always the variable that will go on the x-axis. So the graph for this must look like this. This is your m, and this is your k. Now the graph is going to do something crazy, but the axes have to go like this. And when you find this derivative and you give me the values for k and m, I can find the tangent lines. So that's the bottom line. I go and I solve like this. Derivative of 4m squared is 8m. I took derivative of m in respect to m. I'm moving to the next one. Great, product rule. So, plus copy the first times the derivative of the second, which is 1, and I took the derivative of m in respect to m, plus copy the second, which is m, and then take the derivative of 3k. Derivative of 3k is 3, and then I took the derivative of k in respect to m. Minus derivative of sine k is cosine k. I took the derivative of k in respect to m, equals to, on the other side, 2k. I took the derivative of k in respect to m. Observe that all of these, they have dm, dm, they cancel, and all of them are dk, dm, they stay. And that's actually your derivative. So, I factor out dk, dm, and I have 3m minus cosine k minus 2k equal to, and I kick the other two on the other side that don't have dk, dm. And the final answer is the derivative dk, dm. So it doesn't matter which letters we use. Don't get too much hung up on x's as I write x. And there we go. Tomorrow and Wednesday. It's going to be epic. I can promise you that. My favorite section. Yes. Yep. I hope you're not disappointed, but that's it.
Yeah, it seems so much more complicated.
The trick is to look at the math problem and realize that it's actually simple. But it takes time and practice to actually see it that way.
It's intimidating. There's so much stuff going on at once.
Yeah.
I mean, I get it,
But then it turns out to be very useful when someone says, "Ah, what do you know?" Right? Yeah.
Want to discuss the test
Next week, yeah.
next week? We'll discuss it.
Apparently, some of you already won the exam. We're not even done yet, so.
Well, no, but are we going to finish 311 by this week?
Oh yeah, we should be done with the material this week comfortably. So you can discuss if you want the exam. First, do you want the exam?
Yes.
Yes?
Yeah.
Oh yeah, that went on the stream. Good.
When do you think would be a good day?
Tuesday?
Do you think we'll be ready by Tuesday?
All right.
Yeah.
How do I know?
Because I don't know. Without
I'm going to do my part and that's it.
So we'll be done. I don't know, but then it's going to start. It's up to you guys. Do you want a Wednesday?
I'd say Tuesday.
Wednesday, just do it Wednesday.
All right. Ready?
Oh, yeah.
All right, Wednesday.
Exam Wednesday. That means quizzes start on Thursday.
Yeah, all right, that's fair.
So here are a few exercises directly from textbook for you to enjoy. Find the derivative. See you next week. Find the derivative of e to the xy equal to 2y. And every time I put e in conjunction with differentiation and integrals, you should write me a thank you note. Each one of you separately, right? Because those derivatives are the easiest. Yes.
What would I do with the x and y?
It's a chain rule, right?
So I have to do the one?
Yeah, within.
For up there.
I'm not sure if all of you see that the that e to the xy term is a chain within a product within a chain, right?
Yeah, tricky there.
You got this. Well, it's not e to the x, right? Therefore, it has to be a chain rule. But then you have x times y, it's a product, right? And then because you will be taking the derivative of y prime, implicit differentiation tells you you will be adding dy dx, which is a chain. So chain within a product within a chain. It's complicated to say, but when you start writing it out, it all makes sense as you write it out.
Oh yeah, last
All right, looks like you guys are done. So what's the answer? Yes? Okay.
Zero.
What? 0? No. Why would be 0? So we start with the derivative of e to the x is e to the x, but we have to copy. Now, times the chain rule, which says copy the first, take derivative of the second, times copy the second, take derivative of the first, which is just 1. And that's equal to just 2 dy dx. And now, we have to distribute. So we have x e to the xy dy dx plus y e xy is equal to 2 dy dx. Move this term this way, move this term that way to get dy dx on the same side. So dy dx, and then factor out x e to the xy minus 2 equals to negative y e xy. And finally, this is the answer. So let's take a look at this one more time. I took the derivative. That's all. So let's start. We have a chain rule part here. It's not e to the x. It's not e to the y. It's e to the xy. So the derivative of that has to be itself times the derivative of the exponent. But in exponent, we had the product rule. So this is the product rule here from the xy part. You copy the first, which is x. Derivative of y is 1 times dy dx. Plus copy the second, which is y, times derivative of the first, which is x, which is 1. So y times 1. So this is the derivative of the left-hand side. We use the chain rule and product rule all combined. And then the right-hand side is easy. Derivative of 2y is 2, followed by dy dx, because we took derivative of y in respect to x. And the rest is algebra. Put all of the terms with dy dx on the same side, and then factor out dy dx, and put everything that doesn't have dx dy on the right on its own. And then just divide to get the values. These are some very interesting problems. Never. Never. Yep. All right. Okay, so I'll do the first step. So the derivative of, and I'm just going to make this look a little bit different by cross multiplying and making sure I'm not doing the quotient rule. Or you can do the quotient rule, that's fine. I mean, you can drive here through Holland Tunnel as well.
There you go.
Do you mind doing it with the version when you go over it?
I do mind. I mean, I will, but I do mind. Because one thing about that is only for lazy people, and that's why we learn so much, so we don't have to. Like, because, no,
I did the quotient. I have the whole problem down, but I just made it.
I didn't change it, I just cross multiplied to give you an alternative of how to solve a problem like this. The other one is also valid, so it just takes forever. The other one is not wrong, it's just much more unnecessary work. So we have 2y dy dx minus dy dx is equal to 1. To get dy dx is equal to 1 over 2y minus 1. And then there you go. That's it. That's the solution.
Hold on.
Why, disappointed?
Is that a 1?
No, it's uppercase I. Or lowercase l, pick whatever. This one? When you cross multiply, right?
Every time there's a y, it goes to y prime, and every time there's a y plus, it's our derivative of that times y prime.
What do you mean y
dy
plus?
over dx.
Dy dx is the better notation for the same y prime.
Yeah.
So you say y prime of x is dy dx. Yeah, the original Newton notation was y with a dot on top. And then you had the second derivative, which are 2 dots, which change into primes over time. The notation dy dx is Leibniz's original notation. Leibniz came up with the calculus at the same time as Newton did, except Leibniz didn't apply it to physics and motion. He did other stuff for sake of math and economics and so on. So everyone's stuck with Newton, right? Even though they did it at the exact same time. Because Newton was not a guy who shared a lot of things, so he actually sat on this. And then when he figured out that the Leibniz has the same thing, he was accusing Leibniz of stealing his ideas, because Leibniz figured this stuff out and published it, and Newton didn't, because he used to sit on his results. He invented the entire calculus of variations in one afternoon and just put it in a drawer, never published. That's later, after he did all of this stuff. So Newton was extremely bright, but he wasn't good with this. Is why you have to have both sides, guys. Now we're going into the market. Any one of you who still thinks that communications and English are not important because you are a math and number person, number cruncher, you are going to have a difficult time later on. If you don't take communications class, if you don't learn how to deal with either public speaking or during the meetings, or you're not taking, you can't do well on the interview, you can't do well on many other things that will get you to a job in the first place, and then you have to know your stuff to actually keep the job and do it. So, and if you can't communicate, if you can't write, if you can't do any of these things, that you can't sell your product and your ideas. So you have to do all of these things. There is no one side as, you know, I'm a math person, so, you know, forget about everything else. You have to read books, you have to learn how to communicate past text messaging and past emails, because it's not gonna get you far. First time when you apply for a job and you're waiting, and you're next week or after the interview, and you start your email with yo to check, to check whether you got the position. Yo, thank you very much for having. No, I'm getting emails from students. It starts with yo. Yeah, I actually have one from last week. It starts with yo, professor.
I mean, you are pretty chill, though.
Yeah, but you see, that's the thing that, see, you say I'm pretty chill, right? But see, the professional environment is it's always going to be different from your chill environment, right? I mean, to use your definition of chill. So you have to separate those two worlds completely. And you have to spend a lot of time on writing, and a lot of time on reading, and a lot of time on, and if you haven't taken communications class, you must. Otherwise, you will find it very difficult later to articulate your ideas, to sell your ideas. Those are extremely important concepts. So now the question was, can we do this problem using the quotient rule? And as I said, yes, we can. Then the question was, would I mind? And of course I mind, because it's just a lot of grind. But let's do it so everyone can smile. I'll do it green. It's one color that I usually don't use at all. And it's going to match the back wall. So we have the accent wall right there. See that? So the derivative of y would be dy dx. And then we have a quotient rule, which means this y minus 1 gets squared, and then y minus 1 goes over here. And then derivative of the top is just 1 minus, and then x plus 1 gets copied, and derivative of this is dy dx. And then you have to follow the algebra from there to get this here. Now, in that algebra, you will multiply y minus 1 dy dx, and then you have y minus 1 minus, nope. Actually, hell no. That's better answer. Dx, then move this term to the other side to get dy dx of y minus 1 squared minus plus x plus 1 equals y minus 1. And then you have dy dx is equal to y minus 1 over y squared minus y minus 1 squared plus x plus 1. And now the trick of the century. Observe that x plus 1 over y minus 1 is y, right? So you see that the original problem. So I can replace either this one with y over x plus 1, or I can replace this one. So you can replace those terms and then keep simplifying until you get this. So let's say this x plus 1. What's x plus 1? X plus 1 is going to be y over y minus 1. So x plus 1, this puppy here, is y over y minus 1. So this is just now working on algebra. I'm not even doing anything calc. So dy dx is equal to y minus 1 over y minus 1 squared plus y over y minus 1. At which time you multiply numerator and denominator by y minus 1 to cancel the double fraction. And this thing's just getting more and more crazy, but you have y minus 1 squared in the numerator and then y minus 1 cubed plus 1. No, plus y. Did this help? Yeah, did not help.
Nick, I think we can error actually.
Where?
Isn't x plus 1 y times y minus 1? With the same trick you would use in the beginning anyway, so we can't keep over this.
Where?
You see right there, when you in the purple.
Mm-hmm.
Because then to get x plus 1, you would multiply the y minus 1 to the other side. You get your y times y minus 1. Yeah, like we did initially.
Well, that's what we're doing if you were paying attention.
No,
That's like the proper way, the recorded way.
You see what I mean or no?
So this one would go to the. I don't want to waste time on algebra, but there is a way I can do it on the side. If you bother me later, I'll figure out exactly where the algebra goes. But these two results have to be identical. If you get if y is equal to 1, you get 0. There is a mistake somewhere because they don't give us the same number. Look, y equals 1. Y equals 1 gives me 1 over here, and y equals 1 in this one gives me 0. So there is algebraic mistake somewhere. I'll have to figure this out, and I'll fix it. One more problem, and this is going to be definitely the problem that we want to work on. Find the equation of the tangent line at the point -1, 1. X to the 4 minus x squared y plus y to the 4 equals to 1. All right, so by the time you are doing this tangent line, I'm going to work on this thing, see what exploded. Actually, I have to do something else first. You find the derivative, right? Then you plug the point to get the slope. All right, let's go. While we're still young. Oh my God. I just figured out what was wrong. I flipped the formula.
It was that relationship.
It's not y over y minus 1. It's y times.
Yeah, exactly. It's all time. But it's funny though, because that gives you the same relationship that you used initially, so it just goes to prove that was the best way to do it ultimately.
Yeah.
All the rest of it is just nonsense for no reason.
So now you have y minus 1 to cancel everywhere. And so this cancels with this and with that. And you are left with 1 over y minus 1 plus y, which is 1 over 2y minus 1. It has to work out. It's just I couldn't see it quickly where I made a mistake. So it's either, you see what I did in black? It's either that or the green.
What's obvious?
It could be, well, no, it's like when you go for eye exam, A or B. What's better, 1 or 2? 1.
That's pretty good.
How's this going? We have the tangent line. Yep. Y equals what? Two-thirds x. So the awesome stuff here, we take the derivative, we get 4x cubed minus the product rule, right? Copy the first, derivative of the second, plus copy the second times derivative of the first plus 4y cubed dy dx equals 0. Now here is why, well, now we just do this first. So 4x cubed minus x squared dy dx minus 2xy plus 4y cubed dy dx equals 0. Now remember, no one asked you what is the derivative. You are supposed to find the slope. You can plug here before you solve for anything because it's going to be much easier. So plug in x equals -1, y equals 1, and dy dx equals m. So what do I have? I have 4 times -1 cubed minus -1 squared m minus 2 times -1 times 1 plus 4 1 cubed times m equals 0. I plug everything right away, and now it's much easier to deal with these things. So -4 minus m plus 2 plus 4m equal to 0. So this is 3m equals to 2. M equals, Ryan, good, 2/3. So, and I also have a -1, 1 point. So y equal mx plus b. Y is 1. M is 2/3. X is 1. Plus the b. So b is equal to 1 minus 2/3, 1/3. So y equals 2/3 x plus 1/3. I hope you've seen that every single section that we covered so far has the problem find the tangent line. That is the central problem of chapter 3. Find the tangent line. And you find the tangent line by taking the derivative. Now that derivative could be basic, could be product, could be chain, could be combination, could be implicit, as you have seen, right? Could be any of those. So this is your implicit differentiation. As a grand finale, let's take a look at the higher order implicit derivatives. That means you do the implicit derivative and then you have to do it again. And hopefully not again. And hopefully not again, right? So these guys tend to be a little bit longer, but you should be able to deal with this. So let's see. From the textbook, find the second derivative of what? 31 to 36. Which one?
34.
34 solved. X to the 4 plus y to the 4 equals to 64. Four. All four.
Correct.
Actually, I know I understand. Because you have to settle all of the yeah, because you need to know.
So you're looking for the second derivative here, right? Yeah. Okay, good.
Yeah, because the idea is to be just let this just be the answer, and like, if you really want to use it for that, then that's just not okay, as long as I know what I'm doing, and anyone can just plug it in, as long as you know apply the formula.
Okay, so we are looking for the second derivative, which means that we have to find the first derivative first, which would be 4x cubed plus 4y cubed dy dx equals 0. Now, there is a trade-off here. You are either going to take the derivative now, as is, which means you will be dealing with a product rule here, or you will solve for dy dx, and then you will be dealing with the quotient rule later. There is a trade-off. So whatever you want to do, I'm just going to show on the side that dy dx, right, would be negative 4x cubed over 4y cubed, and then these 4's cancel. So that's the first derivative. Yep. So now, derivative of 64 is constant, right? Right? We're taking the first derivative here in respect to x. So now, you can take the derivative of this, which we could rewrite as a product rule anyway. So I could write dy dx is equal to negative x cubed times y to the negative 3. That's okay, and we have a product rule again, if you want to. So now we are taking another derivative to get to the second derivative. And as you can see now, it becomes d squared y over dx squared. Because d times d is d squared. And then there's a single y there. And dx times dx is dx squared. Equals to the derivative here. Copy the first. The derivative of the second is negative 3 y to the negative 4 dy dx, plus copy the second times derivative of the first, which is negative 3x squared. So now we can put everything together. The negative exponents go down, so this is 3x cubed over y to the 4th dy dx, actually we know what dy dx is. It is negative x cubed over y cubed. Minus 3x squared over y cubed. So when we multiply everything together, we get negative 3x to the 6 over y to the 7 minus 3x squared over y cubed. We could go on and common denominator and all of that stuff. It's not that important right now. If you have to find the tangent, oh, actually no, you can't find the second derivative. You can find the third derivative now, and the fourth, and the fifth, so on. You can keep going. They obviously become progressively more annoying because the expressions keep getting larger. So that's it for the implicit differentiation. Take a break, and then we have 3.9, I believe, after that, which is on logs, which is awesome. Can't wait. Logarithmic differentiation and logarithms. Some of my favorite stuff.